All right, guys. You can see at the top of this slide that our theme for this week is the properties of logarithms. You might want to pause this slide and make sure that you have these properties written down in your notebook or you have a picture of them. You can see that they are all on page 462. So you can copy them down from there. But I just want to, first I want to go through the bottom of this slide and just review the properties that we had with exponents. So if I'm multiplying two bases that are the same together but with different exponents, I end up adding those exponents. That's the product property. And then opposite of that was the quotient property, where if I had the same base and I'm dividing them, then I'm going to subtract those exponents. And then the last was the power property, where if I had a base to some exponent all to a different exponent, I end up multiplying those exponents. You'll notice that these properties are all very similar to the properties of logs, and they are similar, or they are the same almost, because logs and exponents are inverses of each other. So if I had the product property, where I have the log of some base, where some two numbers, different variables, are being multiplied by each other, in expanded form it would be me adding those separately. So log of the same base plus log of the same base of whatever this is over here. So you can see that looks really similar to the product property. The quotient property, if I'm dividing two things, then that ends up being subtraction, because division ends up being subtraction. Multiplication, addition, division, subtraction. And then the power property, if I have some like expression or some number, some variable there to an exponent, then what happens is that exponent comes out front and I end up multiplying it by the whole thing, and that is called the power property. And the reason why we have these properties of logs is we use them to solve logarithms, which will be the theme of the following week. So this week we're getting ready so that we can solve logs, and next week we will be solving logs. All right, so what does that mean? That means if I have something like this, if I want to write this as a single logarithm, these are in expanded form. So just take a step back. These on this page are in this format. I want to make them look like the single term format. So, and I like to do it in steps. So notice here I have something being multiplied times log of 2. Now just a reminder, if I have a log and I don't see a base, that means it's log base 10. I might do this one in 2 steps. I might first say, okay, log of 5, that's still the same. But because this is being multiplied, this is the power property. So it must mean it's an exponent originally. So minus log of 2 to the k power. That's my first step. Let's see if I can zoom in a little so you guys can see better. All right, now this is subtraction. And so if I go back and I look at the properties of log rules, subtraction is division. So then my next step would be to have log of 5 divided by 2 to the k power. And that's, I'm just going to put that in parentheses. Notice it's not log 5 divided by log 2k. That's very different. Because these are both the same base, I can combine it into a single term. All right, so let's try the next one. Notice again, this one doesn't have a power property. This one doesn't have a power property, but here I have this 2. So that 2 is really an exponent to the 6. So my first step might be to write log of 8 minus log. If this was 6 squared is 36. And then plus log of 3. So now if I look at all of this together, subtraction is division, but this is multiplication because it's addition. So what do I do here? Like, what's being multiplied, what's being divided? You just work from left to right. So first step is I'm going to have log of 8 that should be an 8 divided by 36 because of subtraction, plus log 3. So I could either reduce now or wait till the end. So I'm just going to wait till the end. Now this is multiplication, so this is going to be log of 8 times 3, so that's 24, all over that 36. So I can reduce 24 over 36. They're both divisible by 4. Actually, they're both divisible by 12, so I take that back. So we have log, 12 goes into 24 how many times? 2, and 12 goes into 36 3 times. So my final answer here is log of 2/3. So not only do we want just the single term, but we want to make sure we are simplifying it as much as possible. All right, and I will give you a chance to practice these on a different page. This video is going to be a little longer than most just because I want to give a lot of practice problems or ones that I'm going through with you, and then give you an opportunity to go through some on your own. So I apologize for the length of the video. Okay, we see here that everything is log base 7. That means I can combine them. This is multiplication. So first step might be log base 7 of x times y minus log base 7 of z. And that should be a 7, not look like a z. All right, subtraction is division. So my final step and final answer is going to be log base 7 of x, y divided by z. All right. One last one. This one's a little more difficult because I see I have a 1/3 being multiplied by this term and a 2/3 being multiplied by that term, and that means exponents. So my first step is going to be to write those as the exponent that they are. So this is going to be 3x to the 1/3. Make sure everything is to the 1/3 power. It's not just the 3 or just the x. And then this one is going to be log of 3x all to the 2/3 power. Now this plus means that I am multiplying them together. And I'm going to expand this step a little more just so you guys can see what's going on. This is going to be 3x to the 1/3 power times 3x to the 2/3 power. And I want you to notice something here. 3x and 3x is the same. That means they're the same power or same base. And when I'm multiplying the same base but different exponents, I can combine those exponents together. So, and I do that by adding them. 1/3 plus 2/3 is 3/3, which is just 1. So my final answer here is going to be log of 3x. That's it, 3x to the first power. All right. The next slide is for you guys to take some time, and I want you guys to pause this video at this point and do these problems. So hopefully when you pause, it freezes the video, or you could take a picture. I'm going to pause here for a second and give you an opportunity to pause your video before I give the answers that are below. All right, if you guys are coming back, here's the answers. There's one I want to explain, so let me make sure I'm getting all these answers here. I'm not going to explain all of them. Some of them I have some extra notes over here just to show you like how I got the 3/8 in case you were confused. And then this one has n to the 1 over y, or you could have also written it as the y root of n. But I want to talk about this one here, and it leads to this one and some other problems you might see in your task associated with this. Log base 4 of 4. Why did I put that it was 1? Well, if I rewrote this in exponential terms, this is like when we evaluated in the previous section that we learned. In the first week of remote learning. If I rewrote this as an exponent, I'm going to have 4 to the x power equals 4. And then I'm going to use the same base property to understand that this is really 4 to the first power. So once 4 and 4 are the same, my bases are the same, then I know x equals 1. Right? If you end up having questions on that, make sure you email me so that I can be available during some office hours to answer that. I do want to move on to doing the opposite though at this time. So the opposite is, if given these problems in single term, we want to write them as expanded term. So looking at A, I know that I have 6 times x cubed times y. So my first step might be to write log of 6, and when I'm multiplying, I know that's the same as addition with these properties, plus log of x cubed plus log of y. And now I would ask you, if we were in the classroom, am I done simplifying? And hopefully your answer is no, because we have this exponent. And so the power property says that I can put that exponent out in front of that log as multiplication. So now we really have log of 6 plus 3 log x plus log y. And now it's fully simplified. All right, we're going to do a few more examples. So here you see we have some division. But notice that my division has these two being multiplied on the bottom, so how do we adjust for that? So we start out with log of base 2 of x minus, and then I'm going to put parentheses here because I'm really dividing by both of these. And then what's happening to these? Y is being multiplied times z. So this is going to be log base 2 of y plus log, sorry, my lead's running out, log base 2 of z. So you could either leave it like that, I'm fine with that, but if you want to get rid of the parentheses, what happens if I distribute that negative? Then I get log base 2 of x minus log base 2 of y minus log base 2 of z. All right, let's do the last two, and then I'll give you some time for practice. All right, log base 3, 7 is being multiplied by this. So my first step might be to say log base 3 of 7 plus log base 3 of all of this, 2x minus 3 squared. You should recognize that I have an exponent there, so using the power property, I'm going to bring that out front. I get log base 3 of 7 plus 2 log base 3 of 2x minus 3. And then I'm done with that. That's fully simplified. I can't distribute a log to these terms because log isn't a number, it's an operation. So you can't distribute an operation. Operations are like multiplication, division to a binomial pair like this. All right, and one last one. On this one, we need to remember that the square root of x is the same as x to the 1/2. So the square root is actually a fractional exponent. That was a long time ago when we learned that. So just remember that that is true. And then these two are being multiplied. So log base 4 of 5 plus log base 4 of x to the 1/2. And now that I've written this as an exponent, I know that I can put that out front because of the power property and get log base 4 of 5 plus 1/2 log base 4 of x. All right. So just putting my whole slide up there in case you want to pause and make sure you get everything. I have one last slide and it's from some practice for you. So I'm going to switch. Here are your practice problems. I'm going to pause for a second so you guys can take a picture of them or pause your video before I give the answers. All right, so I'm assuming you're coming back and that you actually practiced at least some of them. Here are the answers to those. Notice how long E is because everything was in the square root, so I got to have 1/2 times everything. You could have probably simplified more by distributing the negative there. Also notice on A, log base 3 of 9, you could have kept it like this, or log base 3 of 9 is also 2. And so if you're looking at the answers in the back of the book and maybe it has, instead of the log base 3 of 9, this is why. And everything else should be self-explanatory. Well, it's all new to you, but it's a little more straightforward. A, C, and E were the ones that were a little more tricky, especially if you were converting this whole term into just a number. Anyway, again, I had been just holding my office hours open, but if you guys want office hours, you guys have them on your schedule, just email me. I'll make sure I have a Zoom conference link open, the same one that I've given you guys in email. Anyway, I will, that will be the conclusion of this lesson for the task number 2. And when you're done with task number 2, you can move on to task number 3.